Hi guys, the objective of this video is to classify a whole load of different metamorphic rock samples. In classifying these rock samples, we will be using a lot of terms that we have covered in the previous two videos of this course. If you haven't seen the two videos that come just before this one, I would suggest you maybe go and watch them now because we'll be using a lot of new terms in this video. Here is our first sample. This sample has quite small grains. It is also foliated. As we can see here, there are lines along which the rock prefers to crack. This is a lower grade of foliation, I know, compared to some samples such as this one here, where we can clearly see the foliation. While in this sample we can't see the layers that clearly, the rock prefers to crack off in a certain direction and produces platy flakes if we attempt to break the rock up. These lines along which the rock prefers to crack are our foliation lines. Therefore, we would say that this rock has formed through regional metamorphism, which means the rock has been subjected to heat and pressure. If we think back to our videos on sedimentary rocks, we might say that this sample kind of looks like shale. Sometimes when trying to classify a metamorphic rock, thinking about what the rock looks like can sometimes help us distinguish what type of rock it is. This rock is actually formed through the regional metamorphism of shale, and it is the first stage of metamorphism of shale. It is a slate. This sample is to show you that not all slate looks like this one here. Sometimes slate can have textures along its surface, as this sample can show us. This next sample has slightly larger grains than the last. And some of the grains, which are situated in the right position, are reflecting the light. We can clearly see that the sample has foliation, but this foliation is slightly different to the foliation of the slate. The foliation is shown by the crystals of the same type that have come together to form bands across the rock. The foliation indicates that the rock has undergone regional metamorphism. This sample is a schist. Schist is characterized by having foliation and for having developed crystals or mineral types that will reflect the light. Therefore, we can say quite confidently that this is a schist. Here are some more samples of schist. In each sample we can see foliation, and the reflective minerals which have developed through regional metamorphism. In this sample here, we can see that the sample has almost larger crystal grains again. In this sample, we also have very well developed foliation, which is quite obvious. This foliation has formed as the minerals of the same type have come together and formed bands across the rock. The rock has clearly undergone regional metamorphism. We would call this rock gneiss. Gneiss is very highly metamorphosed. We can tell this through the fact that the foliation is so well developed. Because the grains of the rock are slightly larger, this indicates that the rock has undergone recrystallization, which means it has experienced a lot of high temperatures over a longer period of time. If we then compare this gneiss to the slate, which has much smaller crystal grains, we would say that the slate has undergone a lot less metamorphism because the mineral grains are much smaller and the foliation is a lot less obvious when we compare it to the gneiss. Slate, schist, and gneiss all fit on a continuum and have all formed from the metamorphism of shale. As we metamorphose shale through regional metamorphism and increasing heat and pressure on the material, the shale would turn into slate, then schist, then gneiss. The more heat and pressure we apply, the more highly metamorphic the rock will become. This rock here clearly shows quite large crystal grains. It also shows clear foliation which is quite well developed. The rock has gone through quite a lot of regional metamorphism, and this sample is known as a granitic gneiss. It is called this because it forms from the regional metamorphism of granite. In the granite we can see the feldspar minerals, which are these lighter pink mineral crystal grains here. We can then see these feldspar minerals also contained within our granitic gneiss. These feldspar minerals in the granitic gneiss are the giveaway that tell us that this is in fact a granitic gneiss. Another thing to look for when trying to find a granitic gneiss is to look at the crystal size. Granitic gneiss will often have quite large crystals because it has formed out of the recrystallization of granite, which already has quite large crystals itself. Here we have a sample which has lots of interlocking crystals, and we would call this granoblastic. Therefore, the sample is formed through contact metamorphism. The sample also presents quite light colouring. Furthermore, the sample feels slightly waxy in our hands. Because of the light colouring and the waxy feel of the rock, we think maybe it's marble. In order to test whether our sample is marble or not, we do an acid test. When we drop the acid on this sample, it begins to bubble. This bubbling means that our sample is probably made up of calcium carbonate. Therefore, I'm going to say that this sample is a marble. Here we have another sample. This sample has quite small grains. However, we can see that the sample is made up of interlocking crystal grains. Therefore, we call the rock granoblastic. It is formed through contact metamorphism. It is rather light in colour with small discolorations. I'm going to say that this discoloration is probably just due to impurities within the rock. Because of the light colour, it is probably all made up of a quartz-type mineral. This metamorphic rock is in fact quartzite, which forms through the contact metamorphism of sandstone. Here we have a whole load of different types of quartzite, all of which have formed through the contact metamorphism of sandstone. As you can see, they all have very different colours. This colouring comes from the impurities within the rock. Therefore, we can't really rely on the colour of quartzite to say that one rock or another is quartzite. In order to determine whether a rock is quartzite, we must look at the granoblastic texture of the rock and see the small crystal grains. So this is just to give you an idea of the different types of quartzite we can find. Here we have two samples of the same rock. These two samples have quite small crystals. Both samples seem to be granoblastic. This, along with the lack of foliation, indicates that the rock formed through contact metamorphism. This metamorphic rock has a quite dark colouring, and this indicates that the rock was metamorphosed from a rock with quite dark colouring in the first place. Perhaps it was a mafic igneous rock which underwent contact metamorphism. In fact, these rocks are amphibolite. An amphibolite is formed through the contact metamorphism of basalt or gabbro. Here is the last sample we will have a look at in this video. Here we can see porphyroblasts which have formed. I would say from the shape and colour of these porphyroblasts that the porphyroblasts are garnet. And I would say that this mineral around it is wollastonite. So both of these minerals usually only form in metamorphic situations. However, the wollastonite does look quite granoblastic. This rock is a hornfels, and we specify what type of hornfels it is. It is a wollastonite garnet hornfels. So that's the end of this video, in which we have just been classifying a whole load of different metamorphic rocks. I hope this video helped, and thanks for watching.